Now let us move towards third category of problems. Though it have made it a category, but it is subsumed in the principle of counting or the box method that we did earlier. But I have made it a separate category because JEE has asked so many questions on this idea. Every year there are questions on numbers, and those questions are of different variety. So I wanted to make it a different category, though it can be also considered as a subcategory of the last method. So let us start with it. My first question came in 2022. In this question, they are talking about a 3-digit number. So again, we can make 3 boxes. And what they're saying is exactly 1 digit is repeated 2 times. Okay, so there are many methods to do this question. I am going to use a method that is known as method of destruction. What does that mean is, I am going to write total number of 3 digits that are possible and subtract those numbers which have all distinct digits and all same digits. Now this is quite easy to do. That is the reason I am using this method. Other methods are also valid and can be used. If I want to find total numbers, this first box can be filled in 9 ways. This can be filled in 10 ways, and this can also be filled in 10 ways. So if I do this, what I get is 9 into 10 into 10. Now in the next part, what they are saying is, if all are distinct. Now, if all are distinct, what will happen is this will still be filled in 9 ways. But we have since used 1. Out of 10, only 9 are left, so 9. And then again, we have used 1, so next can be filled in 8 ways. So again, if we multiply, it becomes 9 into 9 into 8. And then in the third part, all are same. See, all can be same in only 9 ways. 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4, 9, 9, 9. So corresponding to third, only 9 cases are possible. If I simplify this, what I get is nothing but 243. A very simple question that was asked in 2022. Now this 2022 question talks about a 6-digit number in which we have to use all of these 1, 2, 3, 4, 5, 7, 9. And all of these needs to be there. So essentially what they want us to write is a 6-digit number that looks like this, where one of the digit is getting repeated out of this, and then all the others are present. So this is an example. So a very important thing in PNC is to visualize what is exactly happening, because most of the students will take some assumption and that assumption will not turn out fine. It is better to write few examples, understand what is happening, and then think of a process that will work out. So you can see that one of these digits will get repeated. So out of this 5, let us choose that one digit that will be repeated. Once we have got that, now you can see that we will have such kind of a scenario. Now this 6 digits can be written or arranged in the form of 6 factorial by 2 factorial, since 1 is getting repeated twice. So our answer comes out to be nothing but D option. Now in 2023 question, they are talking about a 7-digit odd number. So now there are 2 methods. One is the method of destruction, in which we will write total cases and subtract the cases in which this is not happening, or we can do this using a method of construction. Let us try both the methods and see how they work out. So if I talk about the method of destruction, what I can write is, I can write the total cases and minus even numbers from it. This is much simpler to do. So total cases would be nothing but 7 factorial. Since these 3 and these 2 are repeating, so 3 factorial into 2 factorial. Now when we are making even number, what is happening here is, if I am writing a 7-digit number, in my units place, you can see a 2 needs to come. So now in these 6 places, what we need to arrange is nothing but 1, 1, 2, 2, 2 3s and 1 5s. So total ways of arranging this would be nothing but 6 factorial by 2 factorial into 2 factorial. And if you simplify this, this comes out to be 240. Now there could be another method as well, that is method of construction. In this next method, we will try and generate the numbers. Now in this case, you need to be very careful. You need to make cases rather than take any assumptions. So what you need to do is write all the possible cases. So one of those cases would be when in that odd number 1 comes in this place. When 1 comes in this place, so these numbers, this is my case 1. These places can now be filled using 1, 2, 2 2s, 3 2s, 3 5, 2 3s and 1 5. So in this case, your answer will come out to be nothing but 6 factorial by 3 factorial into 2 factorial. One more case can happen in which this last place, we can see 5 can come. Here we were writing 1, if I write 5 here. So now this case also be same as earlier only, because again we have 2 2s, 1 1 and 2 3s to be filled here. So answer comes out to be exactly same as earlier, that is 6 factorial by 3 factorial into 2 factorial. And then there would be a third case. This third case talks about writing 3 here. Now these 6 places can be filled using 1 1, 3 2s, 1 3 and 1 5. So this becomes 6 factorial by nothing but 3 factorial. So you can see that if I want to write the total answer, what is going to be the answer in this case? In the first case, we were getting 6 factorial by 3 factorial into 2 factorial, and that is same as the second one, so I can multiply by 2. And in the last case, 6 factorial by 3 factorial. And if you simplify, you can see this 2 and 2 are getting cancelled. So 2 times 6 factorial by 3 factorial, and this also comes out to be 2 factorial. You can use either of the approaches to get the answer, but the first one is shorter. That is the reason I told you that. Now this 2020 question is again a very simple question. Now what they're saying here is you need to make a 5-digit number, and they have given us a very strict instruction how to make it. So what they're saying is here in the 10th place 2 needs to come. So let us fill 2 here. And now they're saying the answer is this, find the value of k. So now you can see that the first place can be filled using 8 digits, that is except 0 and 2. So there are 8 digits. Now here we can fill 0. So again we will have 8 options. This can be filled using 7 options, and this can be filled using 6 options. So my answer is this. Now if I write 8 into 7 into 6, this is my answer. Now what they are saying is this is equal to 336k. So k is nothing but 8 into 7 into 6 divided by 336. And if you simplify this, this comes out to be 8. If I talk about this 2023 question, it talks about the digits of this number. So you can write this digit as even and odd numbers. So there is 1, then another odd number would be 3, then again 1, then again 3, then again 1. So these are the odd numbers involved, and the even numbers are nothing but 2, 4, 2, 4. Now what they're saying is if we write a 9-digit number like this, even number should come at even places. So in these places, those are my even places, I can only fill even numbers. So let us fill these numbers in these even places. So 4 numbers can be filled in 4 places by 4 factorial by 2 factorial into 2 factorial, because there are 2 digits identical here. If I fill the remaining ones in the odd places, so now for that one, what you will get is 5 factorial, and 3 of these are identical, so 3 factorial into 2 factorial. If you simplify this, you should get your answer, and your answer, if you do, comes out to be nothing but 60. Now this is a very interesting question that came in 2019. Interesting not because the question is tough, but how fast we can solve. That is a competition that we can do in this question. So now the question says that if you make a number that is smaller than 7,000, that is we want to write using this digit, and repetition of digit is allowed. Now this is very important. So 3 things are important that are given in the question. So see, now there is a traditional way of doing this question. So traditional way of doing this question is, first we'll write all the 4-digit numbers. In the second part, we should write the all relevant 3-digit numbers. Then in the third part, we should write all the 2-digit numbers. And in the fourth part, we should write all the single-digit numbers that are relevant. Sum them up, and then come up with an answer. Now, I will shortcut this process. How am I going to shortcut this process? So what we can do is, now if I want to write a number less than 7,000 using these digits, so in this place, what I cannot fill is, I cannot fill 7 or 9. But if I fill 0, 1 and 3, what flexibility do I have is basically, when I fill 0, it will become a 3-digit number. And then if 0 comes in the second place also, then again it becomes a 2-digit number. So all the numbers I am counting at the same time. So what I have done is I have allowed 0 to be filled here. So there are 3 options corresponding to this. Now since repetition of digit is allowed, this can again be filled using 5 options. So corresponding to this, let us write 5. And corresponding to this again also, let us write 5. Corresponding to this again, let us write 5. So what am I getting is nothing but 125 into 3. And if you write that up, this is 375. Now you can see that this is there in the option, but this is not the correct answer. Why? Because they are asking us to write natural numbers. When I do it in this manner, I will be able to write one number where 0, 0, 0 and 0 will come. Now this is not a natural number. This is a whole number. So we need to subtract this 1 from it. So 375 minus 1, 374 will give me my right answer. Now, in this 2023 question, again a very simple question has been asked. Again, we can use our box method. So what we need to do is we need to find a 4-digit number that is greater than 5,000. Smaller than 10,000 would mean a number that is 4-digit number. So now here when we want to write this number, and they have also given us the digit, but here they have mentioned without repetition. So you can see that, understand those problem variations that we talked about earlier, they are now coming into picture. Repetition happening and not happening will change the way how we are approaching it. So now what you can do is this first box, now here what we can fill is nothing but 5, 7 and 9. So this can be filled in 3 ways. The next one now can be filled using 4 ways. The next one can be filled using 3 ways, and this can be filled using 2 ways. So 3 into 4 into 3 into 2 comes out to be nothing but 72. That is nothing but option C. Now this is the divisibility based question. In such questions, we will have to use the divisibility property of numbers. So now when they are saying the number needs to be divisible by 6, that would mean it needs to be divisible by 2 and 3 simultaneously. Now the divisibility of 2 is the last digit. So if you are writing a 3-digit number, this would mean this third digit needs to be an even number. If it is even, it will be divisible by 2. So this is one thing. And if I take this numbers as x, y and z, for being divisible by 3, then x plus y plus z needs to be a multiple of 3. So we'll have to use both of these conditions simultaneously. This is the first part. If I try and do that, you can see that the possible values of z can be only 2, because we need to make number using this and repetition is allowed. So z can be 2 or 4. These are the only 2 possible cases. Now if I take z is equal to 2, in that case what should happen is then x plus y plus 2 needs to be a multiple of 3. So an important question to answer in this scenario is how to make those cases. So there is an efficient technique. So now what I can take is I can take both the numbers at 1. So 1, 1, 1, 2, 1, 3, 1, 4 and 1, 5 till here we can go. So this we are choosing numbers and then we will arrange. So then what we can do is we can start with 2. So 2, 2, 2, 3, 2, 4 and 2, 5. Next what we can do is we can move towards 3. So 3, 3, 3, 4 and 3, 5 and ultimately 4. So 4, 4 and 4, 5. And we can end this by writing 5, 5. So these are the all possibilities that we can have for x and y both. So if I try and write the numbers, what is going to happen is, the first is if I take 1, 3 and 2. So 3 plus 1 is 4, 4 plus 2 is nothing but 6. This is going to satisfy. Then if I take another as nothing but 2, 2, then 2 plus 2 is 4, 4 plus 2 is 6. Again it will satisfy. 2 plus 5 is 7 plus 2 is 9. It will never satisfy. 2 plus 5 is 7 plus 2 is 9. This will also satisfy. 3 plus 3 is 6. 6 plus 2 is 8 will not satisfy. But 3, 4 that is 7. 7 plus 2 would be 9 will satisfy. Then next if I take 4 plus 4 is 8. 8 plus 2 would be nothing but 10 will not satisfy. 9 plus 2 will be 11 will not satisfy. 5 plus 5 is 10 plus 2. This will satisfy. So these are the possible cases that can happen. Now this is for the first one. If I take another part, that is if I take the value of z is nothing but 4. In that scenario what should happen is, now x plus y plus 4 should be a multiple of 3. So again let us see out of these cases which one satisfy in this case. So in this case what is going to happen is, if I take 1 plus 1 it is 2. 2 plus 4 would be 6. This is fine. Then 1 plus 3 is 4. And 4 plus 4 is 8, no, but 5 plus 4 will become 9. And then let us take 2 plus 2, 4, 4 plus 4, 8, again not, but 2 plus 3 is 5 and 5 plus 4 will become 9, it will satisfy. Then 5 plus 2 is 7, 7 plus 4 is 11, no, but 6 plus 4 will become 10, again no. 4 plus 3 is 7, 7 plus 4 is 11, no, but 3 plus 5 is nothing but 8, 8 plus 4 is 12, this will satisfy. Then if I start with 4, 4, 4 plus 4 is 8, 8 plus 4, 12. This will satisfy. Now let us try and write the cases that are getting satisfied in the first one. And this is the third part of my answer. So if I fix here 2, what can be the first 2 values? So based on what we saw, it can be 1, 3. Then 3 plus 1 is 4, it gets satisfied. And now you can arrange them. See, 2 is fixed, but 1 and 3 we can switch places, and this can be arranged in two ways. So answer that we are getting is 2. Then the next is nothing but 2, comma 2 and 2. This can be arranged in one way. And then what we have is 2, 5, 7 plus 2, 9. This again we can do in two ways. Then again what we have is nothing but 3, 4, 2. Again two ways. And then 5, 5, 2. This can be done in nothing but one way. Let us do the same kind of activity for the other one. So the answer for the first case that we are getting is 2, we are getting nothing but 3 times, so 6 plus 2, 8. So what we are totally getting for the first one is nothing but 8. If I move to the second part, what can be the possible scenarios? So what we can have is 1, 1 and 4. 4 is fixed. So again you can arrange in only one way. The next will become 1, 4 and 4. Again you can arrange in two ways. Then 2, 3, 4. Again you can arrange in two ways. And then 3, 5, 4. Again you can arrange in two ways. And then 4, comma 4. And then 4. This you can arrange in one way. If we sum this up, this is also 6 plus 2, 8. And so 8 we are getting from the first one, 8 we are getting from the second one. So 8 plus 8 becomes nothing but 16, which is nothing but our answer. Now let us look into this next question that was asked in 2023. What they're saying is using 1, 2, 3, 4, 5, we need to make 3-digit numbers divisible by 3 and repetition of digit is allowed. And all the three conditions we have read very carefully. So we want 3-digit numbers like this. And what should happen is this needs to be divisible by 3. So if I write this as x, y and z, then x plus y plus z needs to be a multiple of 3, another condition. And then the third part is which can be formed using this, and repetition is allowed. So I can use 1 many times, 3 many times, 5 many times, 8 many times. So there are two approaches. Let us do using both the approaches. So if I use my approach 1, it is smaller. What I can say is, see, since the repetition is allowed, all 3 digits can be same. So now we are making cases, so all same. So now if I take all the digits same, what can happen is 1 plus 1 plus 1 can happen, or 3 plus 3 plus 3 can happen. So what will happen is whatever way you do it, since the same digit is getting added 3 times, it will always be a multiple of 3. So now this can happen in 4 ways. We can go till 8 plus 8 plus 8, and all of these will be multiple of 3. So we have got 4 as our answer for the first case. Another case that we can do is when we have 2 same and 1 different. 2 same and 1 different. Now how does this 2 same 1 different works out? So now what you can do is you can take 2 ones, or you can take 2 threes, or we can take 2 5s, or we can take 2 8. If I do this, so 1 plus 1. Now here, along with this, if I take 3, 5 and 8, so this is 2. If I add 3, it becomes 5. If I add 5 plus 2, 7, and 8 plus 2, 10. So none of these cases getting satisfied. So corresponding to this, there is no solution. If I take the next case, with this I can use 1, 5 and 8. So 3 plus 3, 6 plus 1, 7. This will not work out. 3 plus 3, 6, 6 plus 5 is 11. This will not work out. 3 plus 3, 6, 6 plus 8 is 14. This will also not work out. If I move on to the next part, what I have got is nothing but 1, 3 and 8. So if I take 5 plus 5, it will be 10 plus 1, 11, will not work out. 5 plus 5 is 10. 10 plus 3 is 13, will not work out. 5 plus 5 is 10 plus 8, 18. This will work out. So what will work out is this case. And these two are not working out. So we have got one more area. And then 8 plus 8 now is 16. So again we can take 1, 3 and 5 correspond. So 8 plus 8 is 16 plus 1, 17. Will not work out. 8 plus 8 is 16 plus 3, 19. Not work out. 8 plus 8 is 16 plus 5, 21 will work out. So corresponding to this, we have got 2 cases. And see, if I arrange these, I will get 3 cases corresponding to that. And if I arrange this again, I will get 3 answers corresponding to that. So from here also, I am getting 6 answers. This we have done. Now we can move to the third part. In the third part, what we can say is all different. All of them are different or distinct. How can we do it in this case? So if I do it in this case, what we can write is nothing but 1. So how to make these cases? So we can write it in ascending order. This is a very simple way of making cases. So 1, 3, 5, then 1, 3, 8. Then next you can take 1, 5, 8. Now change the digit. So what you can do is, then what we can take is we can start with 3. So 3, 5 and 8. Nothing else is possible. So if I take these 4 cases, what is going to happen here is 5 plus 3 is 8 and 8 plus 1 is 9. So this is getting satisfied. 5 plus 3, 8 plus 3 is 11. 11 plus 1 is 12. This is also getting satisfied. And 5 plus 8 is nothing but 13 plus 1, 14, not getting satisfied. 5 plus 8 is again 13 plus 3, 16. This, so 16, sorry, not getting satisfied. So you can see that if I arrange this, I will get 6 cases corresponding to this, again 6 cases corresponding to this. So if I add everything, what I have is 4 plus 6 plus 6 plus 6, that comes out to be nothing but 22. So this 2023 question, let us understand what they are trying to say. They want us to make a 4-digit number, and this needs to be divisible by 15. What would that mean? This needs to be divisible by 3 and 5 both. Now, if for the divisibility of 5 is the last digit needs to be multiple of 5. So here we need to put 5 only, because we need to choose a number out of this 1, 2, 3, 4, 5. And the repetition of digit is allowed. Again, we can repeat 5, but the last digit needs to be 5. Otherwise, it will not be a multiple of 15 or 5. And also, all of these should add up to. So if I take this as x, y and z, then what I'm saying for the second condition is x plus y plus z plus 5. This needs to be a multiple of 3. This is what our question is. Now how to solve it? There are 2 approaches. One, like we solved the earlier question by taking cases. So case 1 can be x, y, z are all same. Okay. Then you can have case 2 in which we can say that 2 same and 1 different. And then we can make a case 3 saying that all are distinct. I have already worked out this method or approach in the earlier question. Here I am going to take a slightly different approach, slightly longer, but you should know multiple approaches. So here I will try and write all the cases and then check which one of them satisfies. So how we are going to do it is, let us start writing the cases. So see, 5 is already fixed in the 4th place. So let us write 5 there. And first 3 places, what I can start with 1, 1 and 1, since repetition is allowed. And keep writing numbers in ascending order. So 1, 1, next would be 2. Then 1, 1, 3 can come. Then 1, 1, 5 can come. And this 5 is there in all the cases. Then next one, what we can write is, now here let us increase it. So 2 will come. Then 2, 3 will come. Then 1, 2, 5 will come. Once we have reached there, now let us move forward. So now what you can do is, next we have saturated 2 also. So we can start with 3. So 1, 3, 3 and 5 is already fixed here. Next we can write 1, 3, 5. Now let us start with 5. So 1, 5, 5. Till here we need to stop. Next what we can do is, again in place of first digit, let us start writing 2. So 2, 2 and 2 and then 5. This is one case. Then we can write 2, 2, 3. Then 2, 3, 3, then 2, 3, 5 in a very systematic order, so that we do not miss on 2 places. And this is same in the last place. Let us write more cases, and that will become nothing but 2. Since we have exhausted 3 now, let us start with 5, 5, 5, 5. Now let us start with 3. So 3, 3, 3 and then 5. And then we can write 3, 3, 5. And then again write 3, 5, 5. And then again we have exhausted 3 also. Let us start with 5. So we can go till 5, 5, 5. And the last date is 5 only. So these are the total cases. We have written all the cases that are possible. And since there are not many cases, so this approach will also largely work in most of the cases. Now let us see here. So what we are saying is, sum of all of them should be a multiple of 3. So 5 plus 3 is 8. So this is not the answer. But next is 5 plus 4. That comes out to be 9. So this is acceptable. Next one will become 5 plus 3, 8 plus 2, 10. 5 plus 5, 10 plus 2, 12. This is also fine. And then the next is nothing but, let me write 5 here so there is clarity. So 5 plus 4, 9 plus 1, 10. 5 plus 3, 8 plus 2, 10, 11. 5 plus 5, 10 plus 2, 12 plus 1, 13. Again not acceptable. Here also write 5. And then see, next is 1, 3, 3, 5. So 5 plus 6 is 11 plus 1, 12. So this one is acceptable. We can take this up. The next one is nothing but 5 plus 5, 10, 10 plus 4, 14. Then 15 plus 1, 16. Then 5 plus 6, 11. Then 5 plus 4, 9. 9 plus 3, 12. This is possible. Then 5 plus 5, 10. 10 plus 4 is 14. Again, not possible. 5 plus 6 is 11. 11 plus 2, 13. Not possible. 5 plus 5, 10. 10 plus 5, 15. This is fine. And then the next one is 15 plus 2, 17. And the next one is nothing but 3 plus 3, 9, 9 plus 5, 14, again not possible. 5 plus 5, 10, 10 plus 6, 16, not possible. 15 plus 3, 18, this is possible. And 5 plus 5 plus 5 plus 5 is 20, again not possible. So you can see that this many cases that I have highlighted are possible. And if I arrange this, I will get my answer. So now what I can arrange is the first 3 digits. So this I can arrange, the last part I cannot arrange. So let us do that. So if I start doing that, the answer corresponding to 1 would be nothing but 3. The answer corresponding to next one will again be 3 because 2 are getting repeated. Here also becomes 3. Corresponding to this, you can see again we get is 3. Corresponding to this, you see again 5, 3, 5. All are different. So we will get 6 answers. 3 factorial. And again here we will get 3. So let us sum it up. So what we are getting is 3, 1, 2, 3, 4, 5 times. So 3 into 5 plus 6, that comes out to be nothing but 21. That is the answer to this question. So this is also an approach to solve the similar kind of questions. Now let us look into this next question that was asked in 2019. This question talks about divisibility by 11. Now this is very interesting because most of the students will not remember what was the divisibility of 11. So what they're talking about is a 6-digit number. Let me write it down. So we have x1, x2, x3, x4, x5 and x6. Let us say that this is a 6-digit number. So what does divisibility of 11 says is the sum of the numbers at the odd places like x1 and x3 plus x5. If I take a difference of this with the numbers at the sum of the numbers at the even places, this difference should be a multiple of 11. This is what it says. So now in such kind of question, what you will have to do is first understand what kind of factors of 11 we are looking out here. So if you want to take the maximum that can happen, so if I consider the value of x1, x3 and x5 as 5, 7, 9. So what you can understand here is if I add this and then subtract the least of the numbers available here, that is 0, 1 and 2. Let us see what is the difference. In this scenario, 5 plus 7 is nothing but 12. So this becomes nothing but 21. And if you subtract thing, it becomes 19. So what we can observe here is, see, this can have a value between 0 to 11. So there are two cases possible. One, this value of n can become 0. And another thing is the value of n can be equal to 1. So we are looking into two values. So let us take these two cases. If I take n is equal to 0, in that case, what we are looking is x1 plus x3 plus x5. And if I subtract this from x2 plus x4 plus x6, their difference should be equal to 0. So that would mean x1 plus x3 plus x5 should be equal to x2 plus x4 plus x6. Now see, question clearly says that we have to make this number using this 1, 2, 5, 7, 9. So now if I try and make pair, so let us keep this 0 and 9, 0, 7 and 5 in one group. And another group I can consider is 9, 2 and 1. If I consider this group, you can see that 0 plus 7 plus 5 is nothing but equal to 12. And 9, 2 and 1 again will be equal to 12. So now you can see that both of them can take either of the values. So we have two cases here. In the first case, let us say this x1, x1, x3 and x5 are taking values from this 0, 7 and 5. And correspondingly, my x2 and x2, x4 and x6 are nothing but equal to 9, 2 and 1. If this happens, see, corresponding to this, let us say how many cases would be. Now your first digit, that is x1, cannot be 0. So this can be arranged in nothing but 2 into 2 ways, that is 4 ways. And the second part that we are writing here, if I arrange this, the possible scenarios then can be nothing but 3 factorial. So that is nothing but equal to 6. So this case will happen in nothing but 4 into 6 ways, that is nothing but 24. This is what we are getting for the first part. Now we can also exchange the values. So if I exchange the values, in that case, what we will have is x1, x2, x3 and x5. Now this part can take the values as 9, 2 and 1. So this can happen in 3 factorial ways. And then the other part, that is nothing but x2, x4 and x6. And this can happen in 0, 7 and 5. If this happens, then now you can also give this 3 factorial values, because x2, second, fourth and sixth place can be 0. There is no problem with that. So you can see that the total cases corresponding to this next part would be nothing but 6 into 6, that is 36. Okay, now this is the first part. So for n is equal to 0, what is the final answer that we are getting? So in the first case, the answer can be 24. In the second case, the answer would be 36. So for corresponding to first case, the answer is 60. Now let us take another scenario. So this is my first case. Now let us move on to the second part. In this second part, what we can do is basically, now you can consider the value of n is 1. So what we are looking is the difference can be in such a manner that x2, x4 and x6 can be in such a manner that it becomes equal to 11. Now you can do some hit and trial and you will figure out that no case will satisfy this scenario. So we'll get no answer from this one. So our answer to this question becomes 60. That is nothing but option A. Now this second question is based on the idea of cyclicity. In this next question, what we are going to understand first is, see what will be the impact on the last digit when you raise 3 to some power. So if I raise 3 to the power 1, the last digit is 3. If you raise 3 to the power 2, then the last digit is nothing but 9. If you raise it to power 3, the last digit would be 7. And if you raise it to the power 4, the last digit would be nothing but 1. And after this, you can see that the same pattern will keep on repeating. So this is known as cyclicity of numbers. Now, if I do the same thing for 7, 7 raised to the power 1 comes out to be 7. 7 raised to the power 2 will come out to be 49. So 9. 7 raised to the power 3. And again, if you multiply it by 7, will come out to be 3. And 7 raised to the power 4, the last digit will come out to be nothing but 1. So now what they're saying is, if I take this number and if I add this number, what will happen to the units place, because divisible by or multiple of 10 would mean last digit needs to be 0. So that can happen in this first case and in this third case. So whenever the number that is written, that is your n, whenever I say it is in the form of 3m plus 1, this condition will satisfy, or 3m plus 3. Their last digits will add up and become 0 and hence multiple of 10. So this is going to get satisfied. So now let us write those numbers. So first of this number of the first type would be nothing but 13. The one in the second category would be 11. Then what we are going to get in the next category is 15. And in the first one, we are going to get 17. And this will keep on moving. So what you can observe here is, if you observe this pattern of numbers, so you can observe the value as 11, then 13, then 15, then 17, and the last would be nothing but 99. You can see that this is an arithmetic progression. So if I want to find total number of terms, it is very simple. 99 can be written as a plus m minus 1 or m dash minus 1 into d. So this becomes 99 is equal to 11 plus m dash minus 1 into 2. So the value of m dash comes out to be 45. So there are going to be 45 such terms. Hence the answer of this question is 45. Now this next question is a very interesting question. It talks about the number of 3-digit numbers that are divisible by 3 or 4 but not 48. So what we want is number of elements in 3. 3 means 3-digit number divisible by 3. Union number of divisible by 4 minus number of 3-digit numbers divisible by 48. Now here we can use n of a plus n of b minus n of a intersection b. See, in mathematics, we also call this as inclusion-exclusion principle, but I always prefer to use set theory rather than using complicated principles. So now let us find all of these values, substitute and get the answer. So if I want to find n of 3, that would mean if you take 999, that is the highest 3-digit number, and divide it by 3, take greatest integer function, then take 99 and divide by 3. So what we are doing is we are counting all the 3-digit numbers which are smaller than or equal to 999, and then we are removing the 2-digit numbers, 2-digit numbers divisible by 3 from that. So what you are getting from here is nothing but 333 minus 33. It comes out to be nothing but 300. then we can find nothing but n of 4. Again, we can use the same technique, 999 divided by 4 minus 99 by 4. By this, we'll be able to remove the 2-digit numbers by subtracting. If I divide by 4, it comes out to be 2, and then 19, that will be 4, and then 39, so 4 into 9, 249. And if I divide by 4, it comes out to be nothing but 24. So this comes out to be nothing but 225. And the last part is nothing but n of 3 intersection 4. So 3 and 4 both would mean 3 intersection 4 would mean multiple of 3 and 4 both. That means multiple of 12. So again, I can take this 999 and divide by 12 minus 99 divided by 12. And if I do this thing, so what I need to do is whatever we got earlier, this 249, if I divide by 3 more, so it comes out to be nothing but 3 into 8, 83 it will come. And the next part, if I divide by 12, it comes out to be nothing but 8. And if I simplify this, it will come out to be nothing but 75. Now, one more thing we need to find, that is n of 48. For doing that, again, we will repeat the same activity. 999, number divided by 48, and take greatest integer function. 99 by 48. So if I simplify this, the first part comes out to be 20 and the second part comes out to be 2. So this becomes 18. If you put all the values in the formula above, what we are getting from here is nothing but 300 plus 225 minus 75 and minus 18. This comes out to be nothing but 432. That is nothing but option D. Now this next question is nothing but a more complicated form of the last question. So what happens is, again, we have to make 3-digit numbers only, and we have to find divisible by 2 or 3, but not divisible by 7. What would this mean? Number of elements in 2 union 3 minus number of elements that are multiple of 7 and 2 would be nothing but multiple of 14. Union 7 and 3, that would be nothing but 21. So I am taking this 21 because 7 into 3, and 14 because nothing but 7 into 2. So this we need to find. So now in order to find this, we'll have to find n of 2, then n of 3 minus n of 2 intersection 3. And then we will have to subtract n of 14 plus n of 21 minus n of nothing but LCM of 7, 2, or 14 intersection 21. So now this can be further simplified and written as n of 3. Intersection of 2 and 3 would be nothing but number divisible by 6, and then number of elements divisible by 14, number of elements divisible by 21, number of elements divisible by 42. Because LCM of 14 and 21 would be nothing but 42. All we need to do is find this value. Now there is a standard formula for doing so. This we can find by putting greatest integer function like this, and then for 2-digit numbers, they will have to subtract that, because we only want to find the answer for this. We will write this. For 3, again 999, and this we did earlier also, divide by 3 greatest integer function minus 99 by 3 greatest integer function. Similarly, we can find for 6 also, 999 by 6 minus 99 by 6 greatest integer function. So by doing this, we have done the first 3 parts. By finding the remaining values, again I can do the similar kind of calculation. And for finding n of 14, again we can take 999 by 14 minus 99 by 14 greatest integer function. Then again n of 21 can be written as nothing but 999 by 21 greatest integer function minus 99 by 21 greatest integer function. And ultimately n of 42 is equal to 999 by 42 greatest integer function minus 99 by 42 greatest integer function. And if you put all of these values and simplify this expression, this comes out to be nothing but 5. Now this next question goes one step ahead from the last question and talks about a 4-digit numbers whose greatest common divisor with 54 is 2. Now if I write prime factorization of 54, it can be written as nothing but 6 into 9, and that can eventually be written as 2 into 27. So what does this question means is, if I write a 4-digit number, and it should be divisible by 2, but it should not be divisible by 3. That would mean what I want to write is number of elements in 2 minus number of elements in 2 intersection 3. If I find this value, I will be able to get my answer. Now we already know that if I want to find 2 intersection 3, it means nothing but 6. And n of 2 I can find as nothing but 1, 2, 3, 4 divide by 2. Write 999 divided by 2, apply greatest integer function. And then remove the 3-digit numbers out of this. And then similarly we can find 6 by writing 99999 divided by 6 greatest integer function minus 999 divided by 6 greatest integer function. And if we simplify this, my answer comes out to be nothing but 3000. Now this question that was asked in 2021 improves on the idea that was asked in the earlier question. Now what they're saying is a 3-digit number whose greatest common divisor with 36 is 2. Now this is very interesting because if you write prime factorization of 36, you will get 2 into 2 into 3 into 3. So you can see that the total factors that might appear would be nothing but 2, then 4, then 3, then 9. And if I combine 2 and 3, it becomes 6. 2 and 9, it becomes 18. 4 and 3, it becomes 12. And 4 and 9, then it becomes 36. So we need to account for only those factors which have only 2. What does that mean? If I draw it in the form of a Venn diagram, this is how it looks like. So let us say that this is a set of elements of 4-digit number which have 2 as a factor. So this is the 4 wala part. And now what they are saying is, see, so if you have covered this, by default all the factors are 4 are covered. So by covering this, we have covered 12 also, 36 also. There is no problem. So if I consider 3, then we are going to get a set like this. This is a set of 3. And you can see that this set of 3 will have an intersection with this 4. And these are nothing but multiples of 12. And then we have this another part, small part. And these are nothing but multiples of 6. This is what we are talking about. So if I write it in the form of a set theory statement, so what were the number of elements of 2 minus number of elements of 6 union 4. This is what we need to find. So if you do this, n of 2, we can find this will become n of 6 minus n of 4 plus n of 12. Intersection of 6 and 4 would be nothing but 12. Now what we need to do is put this value. So if I want to find n of 2, n of 2 comes out to be nothing but 999 divided by 2 minus 99 by 2. N of 6 will come out to be 999 divided by 6 minus 99 by 6 greatest integer function. And then if I want to find n of 4, it is nothing but 999 by 4's greatest integer function minus 99 by 4 greatest integer function. And finally n of 12, if I want to find, it comes out to be 999 by 12 minus 99 by 12's greatest integer function. Now we can substitute all of these values. We can find these values, put it here, and the answer comes out to be nothing but 150. So this understanding through set theory, what exactly is happening, is very important for solving this question. Now this 2022 question is very interesting and quite different to other questions. What they're saying is, if you make a 4-digit number, how many digits or how many numbers can be such that so the digit at the first, second and third place is divisible by the digit at the fourth place or the last place. So now what you can do in such kind of a question is start making cases. In our first case, what you can do is we can start with the greatest number like 9. If I put 9 here, then here a number divisible by 9 can be only 9. But in this place, I can put 0 and 9 also, and here again 0 and 9 also. So you can see that the number corresponding to 9 would be nothing but 4. The similar kind of case will happen with if I put in place of 9 8 also, and this will also happen for 7, this will also happen for 6, and this will also happen for 5. So for all of these 4 cases, we will have again 4 cases. Now once you have observed this, our life has become easy, and let us take this as case 1 only. So you can see that in this first case, what we are getting is nothing but 20 cases. Now after this, a shift is going to happen, because now if I put 4 here, corresponding to this, I can here write 4 and 8. At the same time, this place can be filled using 0, 4, 8. So you can see that the total cases are 2 into 3 into 3. And that comes out to be nothing but 9 into 2, 18. There could be a third case when in this units place, what I can do is I can put 3. So if I put 3 here, this first place can be filled using 3, 6 and 9. And the second place 0, 3, 6, 9. So answer becomes nothing but 3 into 4 into 4. And that is nothing but 16 into 4 is nothing but 48. And then if I move towards the next case, that is the fourth case. Now what we can do is in this unit place, I can also put 2. So if I put 2 here, and in that scenario, my first place can be filled using 2, 4, 8 and 6. There are 4 scenarios. Here 0 will also get added. 2, 0, 2, 4, 6, 8. So the answer becomes nothing but 4 into 5 into 5. And you can see that that is nothing but 100. And now we are missing out on a very important case. And that important case is our fifth case, in which the units place digit becomes nothing but 1. Now it becomes 1, then here you can put any 9 digits. Here you can put any 10 digits. Here you can put any 10 digits. So the answer corresponding to that becomes 900. Now let us add it down. So first answer was nothing but 900. Another one is 100. Before 100, what we got was nothing but 48. And before that, what we got is 18. And then before that, it was 20. So if I add everything up, it comes out to be nothing but 1086. And that is nothing but the answer to this question. Now this 2023 question was extremely intelligent and interesting. In this question, they are asking us to make a 5-digit number. And in this 5-digit number, what they're saying is we need to arrange all the 5-digit numbers in such a manner that, and tell us that at what number this 42923 will come. The repetition of digit is allowed. So this is kind of a question of rank, but given in terms of numbers, and repetition is allowed. That is a very interesting point that the question maker has made. So now let us look into this, how to solve this question. If I want to solve this question, let us start with basics. So if I start with, let us say 2 here in this place, then what can happen here is in these 4 places, since repetition is allowed, I can fill this using 6 digit, 6 digit, 6 digit, 6 digit. So you can see that corresponding to this, there are 6 raised to the power 4 ways. Now you can see that until I reach 4 here, and I can also fill 3 at this place. So corresponding to 3 also, you can see that if I fill 3 here, again I can fill this 4 boxes using same 6 things. So again corresponding to this, there will be 6 raised to the power 4 ways. So we have started with 0, then 2, then 3 is covered. So now 4 will come. So 4 is fine. Then let us move on to the next step. Now you can see this next step. Now here what we want is nothing but 2. But before 2 there is 0. So if I fill 0 here, corresponding to this, now I need to fill these 3 boxes. So there are 6 raised to the power 3 ways. And in the third step, you will see this will also match. So here you will put 2. Then this is matched. Now the next digit is nothing but that we want to match is nothing but 9. But before 9, there is 0, 2, 3, 4 and 7, 5 digits. So you can see that corresponding to everyone, let us put 0 here again to start with. Then you will have to fill 2 places, 6 square will come. And now this will happen for 0, 2, 3, 4 and 7. So 5 times this is going to happen. And after that, the next step will come where 4 will also match, 2 will also match, 9 will also match. Now let us go to the next place. Then we want to match 2. But before 2, 0 will come. And if I put 0 here, then corresponding to that there are 6. But in the next step, if you write it down, now 4, 2, 9, and again 2 is matched. So only one place is left. Here what we can do is, first we can start with 0. Then we can fill 2 here. And then we'll fill 3 here. So corresponding to this, 3 more ways will come. If I add this up, I should get my answer. So my final answer becomes 6 raised to the power 4 into 2 plus 6 cube plus 6 square will come 5 times plus 1 6 and then 3. If you add this up, you get your answer. Now if we start with this next question, in this next question, the similar kind of question as earlier as asked. It is only that now we are making 5 digit numbers using digit 1, 2, 3, 4, 5, 7. Repetition is allowed still, but we are writing it in descending order. This is very important. So what they are asking is, what is the serial number of this? So now what we will start is, when we are starting making this 5 digit number, so what we need to take care is the descending order. That is a very important thing. So I need to start with 7 here. And then you can see that the next iteration that will happen will have 5 here. And we need to reach 3. So after 3 we can stop. Now this can be done since repetition is allowed and we have 5 digits. So 5 raised to the power 4. This can be done in 5 raised to the power 4. Now here again we'll start in the ascending order. So 7 we will put. And after we need to reach 5. Then there are 3 places to be filled. So 5 raised to the power 3. Then next what we can do is we can put 5 here. But then 5 matches. In the next place, now you can put 7 here. Again 2 places to be filled. So 5 square. And again 3, 5. And then again after 5, 7, 5 will come. And you can see the next, again we can fill in 5 square. And then we can move on, keep on doing this. So 3, 5 was there. And after 5 you will find 3 here. Now this 3 matches to the description. So in the next place, you can again start with 7. And here you will have 5 options to fill this place. And then what we have is nothing but 3, 5, 3. And the next important digit is nothing but 5. And again there will be 5 cases corresponding to this. And then 3, 5, 3, and then 3 will come. Because 1, 2, 3 were there and this 3 matches. So now it is the only last digit that you can fill, and this is 7 only. So this becomes 1. So if I add this up, what am I getting? I am getting 5 raised to the power 4 2 times. And now plus nothing but 5 raised to the power 3 1 time. Then 5 square again 2 times. Then 5 again 2 times and then plus 1. If you add this up, it comes out to be 1436. Now this next question is again a very interesting question asked on numbers. So what they're saying is, you need to write the numbers in such a manner that x1 is greater than x2 is greater than till x6, and all of these numbers are greater than 0. If I write this in ascending order or increasing order, then the sum of the digits of the number at 72nd place. So now we can see that the same rank based number question that we did earlier, we need to do in reverse order. So let us see how to manage this question. So what we are going to do is, we are going to start filling the first place first. So if I put 1 here, then for filling the remaining 5 places, and out of 8, 2, 3, 4, 5, 6, 7, 8, 9, out of this 8 digits I have, I can choose any 5. So you can see that the answer that I will get is 8 into 7 into 6 by 3 factorial, and that is nothing but 8 into 7, that is 56. You can see that the first 56 numbers that are going to come will have 1 at this place. Now if I change this to 2, let us see what happens. 4, 5, 6, 7, 8 and 9. So there are a total 7 digits. So out of this 7, I can choose any 5. And since we are putting in increasing order, we do not need to arrange them further, because arrangement they have already given to us. So if I do this, what I'm getting is 7 into 6 by 2. And this comes out to be nothing but 7 into 3, that is nothing but 21. Now if I add this to, what you can observe here, what you are getting is nothing but 77. So we have exceeded this number, that is 72. So it is not recommendable that we go till here. So this we cannot do. We need to start counting beyond this. So we need to go further deepen, because the number that we are talking about, 72nd number, will start with 2. So we cannot cross that. So now if I take the second number, let us put 3 here, because numbers are in ascending order. So if I put 3 here, now in that scenario, I need to fill this 4 places by 4, 5, 6, 7, 8, 9 out of this 6. So out of this 6, I need to select any 4. So 6C4. So if I take 6C4, my answer comes out to be 6 into 5 divided by 2. And that is nothing but 3 into 5, that is nothing but 15. So you can see that once I add them, what I am getting is nothing but 71. And from here, if I want to write the 72nd number, now I understand what is going to happen. It is going to start with 2. Then we will write 4 here, then 5, then 6, then 7, and then 8. So this is how I'm going to write it. And if I write it down like this, then the sum of these numbers is going to give me my answer. So my answer becomes 2 plus 4 plus 5 plus 6 plus 7 plus 8. And if you actually do it, this comes out to be nothing but 32. Now this 2023 question is very interesting. It talks about a scenario when probably you have lost your pin of your ATM card, and now we are trying to decipher that how many times I need to check in order to get the pin right. Now there are 2 conditions that they have given here. The first condition is that the greatest number, the guy who has done this, remembers is 7. So if this pin is of 4 digit, x1, x2, x3, x4, the greatest of these numbers he remembers is 7. So what that means is the digits that are involved are 0, 1, 2, 3, 4, 5, 6 and 7. And we definitely know that this one is involved. The rest 3 will come from here. This is what we know after this statement. One more statement what he is giving is, if I add x1 plus x2, that will be equal to x3 plus x4. So sum of the first 2 digit is equal to the sum of last 2 digits. So these are the 2 conditions that are given to us. Now we have to figure out that how many such possibilities are there for x1, x2, x3, x4, and that he could type and check in order to get the correct pin. So now let us start by making cases. What are the possible cases? So x1, x2, x3, x4, let us take these and understand what can be the possible cases. So what I can do is I can start by taking the value of x1 as 7. Now I can take 7 in the first group also and 7 second group also. So corresponding to every case, we'll see how many cases are possible. Now let us start from here. So if I take 7 here and consider x2 0 here, so what we have is nothing but we have taken this as 7 plus 0. So corresponding to this, x3 plus x4 should be equal to 7. Now what we have done here is we have removed this part and we have removed this. So what we are looking into, if something can add up in between taking these 2 and could become 7. So if I take 6 here, it will become 1. If I take 5 here, it becomes 2, and it can be done in a very systematic manner, 4, 3. And then these arrangements, what will happen between them, we can calculate it using PNC. First, we are trying to write the cases. Inside the case, what variation will happen, that we'll see later on. Now, what I can do is this, if I keep 7 and make 1, then corresponding to this, another case would be, let us start with 6 again. So what I want is sum is 8, so 6 plus 2. Then if I take 7, 1, so 5, 3 can also happen. And then 4, 4 can happen, but repetition of digit is not allowed. What they're saying is digits are different. So we do not need to consider that. If I move further and take 7, 2, then with 6, what I will require is nothing but 3. So 6, 3 is definitely possible. For 7, 2, 5, 4 is also possible. And beyond this, it will not make any sense. Next, if I write 7, 3, it is nothing but 10. And for that, I will require 6, 4. That will also become 10. And 5, 6, 5, 5. But repetition is not allowed, so we cannot take that. If I take 7, 4, it becomes 11. Then only possibility is 6, 5. So what we can see that total we have got 1, 2, 3, 4, 5, 6, 7, 8 and 9 cases. Now let us take any one of these cases and see what are the internal possibilities that can happen. So if I take my first case itself, so my first case says that the numbers are nothing but 7, 0, 6, 1. So now one thing what you can do is we have taken 7 here and we can reverse and write this as, so now first we can reverse between them. So if I take my first as 0, So this we can arrange in two ways, and here also we can arrange in two ways. We can, instead of this, we can write 1 6 also. So you can see that corresponding to this we have two choices, corresponding to this we have two choices. Also, instead of putting 70 here, I could have put it in the second place. So instead of writing this, what we have written here, alternatively, I can also write 6, 1 here and 7, 0 in the last two digits. So for this again, two variations will come. So total variations are nothing but 2 into 2 into 2. So corresponding to every case, there are 8 variations that we have. So total variations becomes 8 into 9. That is nothing but 72, which is nothing but our answer. Now, slightly different variation of the same type of question. So what we are writing in this question is, we need to make a password consisting of either 6 letter or 7 or characters, or what we want is nothing but 8 characters. What we are saying is these characters can be either these alphabets or these numbers. So total ways of filling each one of this is 10. So I can fill this in 10 different ways. This can also in 10 different ways, so on and so forth. Now what they're asking is in how many ways this can be done so that at least one character is a number. So now this question seems to be very easily done if you use destruction method. So what we can write is, we can write total number of ways and subtract when none of them is alphabet. None is alphabet. None is number. Sorry, alphabet we require. So this should give us the answer. So it is quite simple. Now for a 6-digit number, the total numbers could be nothing but 10 raised to the power 6. For a 7, it would be 10 raised to the power 7. And for a 8, it would be nothing but 10 raised to the power 8. Now for the first case, if none of the alphabets, none of the numbers come, then I can fill this first box in nothing but 5 ways, which are nothing but alphabets. If I do it, it becomes 5 raised to the power 6. The second will become 5 raised to the power 7. The third will become 5 raised to the power 8. If you simplify this, we get our number 70. Now this, if I simplify, it comes out to be nothing but, what they have given is nothing but alpha times 5 raised to the power 6. So if I divide it by 5 raised to the power 6, the value of alpha comes out to be 2 raised to the power 6. And plus 2 raised to the power 6 into 10 plus 2 raised to the power 6 into 100. And then minus 1. In the second case, what we'll have is nothing but 5. And in the third case, we'll have nothing but 25. If I simplify this, the value of alpha comes out to be 7073. Quite a simple question. If you look into this 2020 question, in this question, what they're asking is, they are talking about permutations already given in the form of B1, B2, B3, which has 4 elements. These are saying these are 4 element permutation. Notice the word, they have already given you permutation. You do not need to do it. And now what they're saying is, in how many ways can this be done so that no element is equal to each other. And another thing that they are giving is, there are two conditions, B1, B2, B3, either they are consecutive, or B2, B3, B4, either they are consecutive. So if I take my set P as nothing but B1, B2, B3 being consecutive, and set Q as nothing but B2, B3, B4 being consecutive. So we can apply set theory and write number of elements in P union Q. So if I write like this, then N of P plus N of Q minus N of P intersection Q should give me my answer. So now let us write number of elements like B1, B2, B3 are consecutive integers. We are taking these numbers from nothing but 1 to 100. So what can happen is, basically you can start with 1, 2, 3, and this is the first one. The next can become 2, 3, 4. And if I keep on going like this, then the 3 numbers can ultimately be written as 97, 98, 99, and 98, 99, 100, like this. So you can see that there are total 98 ways to do so. So the first 3 numbers B1, B2, B3 can be done in 98 ways. Once you have done that, since no digit or no number is same between B1, B2, B3, the next one can be chosen by the remaining. So if I, for example, if I take this first one, so now the B4 can be chosen from 4 to 100. And these are nothing but again 97 numbers. So the next one can be chosen in 97 ways. So the first part becomes 98 into 97. Second will also be same. there is nothing different. But in the fourth part, now let us say what is happening. So when we are seeing both of them happens, then what will happen in that case? In that case, whatever we are getting are 4 consecutive numbers, like 1, 2, 3, 4. So again, if I write it in like similar manner, 97, 98, 99 and 100 are going to be the last 4. And again, you can see in the last case, they are going to be nothing but 97 cases. So minus 97. If we simplify this, the answer comes out to be 18915. Now in this 2021 question, what they're asking is sum of all the 4-digit numbers that can be found using 1, 2, 2, 3. So usually such questions, when given in arithmetic progression, if the digits are in arithmetic progression, we have a shortcut. But since the digits are not in arithmetic progression, we cannot apply the shortcut. We will have to go using long cut, because even the numbers that are given, 2 of them are same. So none of the shortcuts will get applied, and we'll have to do it using our core method. So what is the core method? First, let us count what is happening at units place, and then understand the contribution of each of these. So if I put 1 here, then this 1 is going to come how many times? Now in these 3 places, I will have to put 2, 2 and 1, 3. So this will come in 3 factorial by 2 factorial ways. And since 1 is coming, this is the contribution. And since the place value is 0, this will come. Similarly, if I put 2 here now, things will change slightly, because now we have 1, 2 and 3 to be arranged. So 3 factorial ways to arrange, then 2, and then place value 10 is to the power 0. Further, if I want to do then 1, 1, again here I can put 3. So you can see that here again you have 2, 2, 1 to arrange. So similar as the first case. So this becomes 3 factorial by 2 factorial. And into 3, and then the place value. So what we are getting for the units place, let us write it down. So what we are getting is nothing but 1 into 3 factorial by 2 factorial plus 2 into 3 factorial plus 3 into 3 factorial by 2 factorial into 10 raised to the power 0. This is what we are getting. Now if I know this, then 10's place is not very difficult to calculate. The similar thing will happen. It is just that the place value will change. So in that part, if I simplify, similar kind of expression we are going to get. There is going to be not much of a difference there. Just the place value that was earlier 10 raised to the power 0, it become 10 raised to the power 4. So if I do this for all the places and add it up, what is going to happen is we are going to get an expression that looks like this: 1 into 3 factorial by 2 factorial plus 2 into 3 factorial plus 3 into 3 factorial by 2 factorial. And then 10 raised to the power 0 from the first part, 10 raised to the power 1 from second part, 10 square from the third part, and 10 cube for the fourth place is going to come, and this is going to be our answer. And if I do this, what I can write from the first place is nothing but 3, and this becomes nothing but 12, and this becomes nothing but 9, and this becomes, if I simplify, 1, 1, 1, 1. So this is nothing but 24 into 1, 1, 1, 1. That comes out to be 2, 6, 6, 2, 4. And that is nothing but option 1. Now let us look into this another question that was asked in 2022. So unlike earlier question, we talked about sum of the digit. This question talks about product of the digits. So if I take my 5-digit number as x1, x2, x3, x4, x5. So what they are saying is, if I do the product of x1 into x2 into x3 into x4 into x5, this is equal to 36. An interesting thing is, if you factorize this 36, it can be written as 2 into 2 into 3 into 3. So this is how the prime factorization of this number will look like. Now if I want to make this number, let us see what kind of cases would be possible. So let us start with the maximum values of the digit. So maximum value can happen at 9, and if I multiply other 2 digits, it becomes 4. So one of the possible scenarios is this might happen, and this is how we'll find a 5-digit number. So this is one of the possible scenarios when the digits are 9, 4, 1, 1, 1. So what I'm going to do is I'm going to start with the maximum number and move towards the minimum numbers. Another way to do the same thing would be to write the same thing as nothing but 9, 2, 2, 1, 1. This is also another possibility. Another possibility of expressing it would be nothing but, let us take another biggest digit that can happen is nothing but 6. So if I take one of the numbers as 6, another number can also become 6, and then the remaining numbers can be 1 1 1. If I take 6 3 2 1 1, this is also possible. Once I have taken this digits, now let us say the next can be written as nothing but 3. So I can write 3 3, and in fact the next can be 4. So if I take one of them as 4, then 4 into 3 into 3 into 1 into 1, and towards that I can take 3, then 3, then 2 into 2 into 1. We have these 6 cases. Now let us see arrangements in these 6 cases. So if I take this first case, it can be arranged in 5 factorial, and 3 are same, so 3 factorial. The next can be done in 5 factorial by 2 factorial into 2 factorial. The next can be done by 5 factorial by 2 factorial into 3 factorial. Next can be done by 5 factorial by 2 factorial. Next can be done by 5 factorial by 2 factorial into 2 factorial. And the last one can be done by 5 factorial by 2 factorial into 2 factorial. Now if you add up all of these cases, and we'll have to add because we add the cases, what I get is nothing but 180, which is nothing but answer up to this question. Now in this 2023 question, they are asking that if I arrange 1 2 3 4 5 6 7, how many cases are possible where neither the string of 153 nor the string of 2 4 6 7 occurs? Now such kind of questions were earlier asked in terms of words. Now they have asked the same question in terms of numbers. So this is an application of set theory in PNC. We call this as principle of inclusion exclusion. So if I take my first case A as nothing but the string of 1 5 and 3 occur, and if I take my case B as nothing but when the string of 2 5 6 7 occur. So what the question says is number of elements in when A should not also happen and B should also not happen. This is what they are asking. If I apply my De Morgan's law, what we have learned is if I take complement over both A and B, the middle sign, this sign will get flipped, and now this can be written as total cases minus number of cases in A union B. So this is what we have blended up. Now let us try and find the value. So if I find total number of permutation of 7 letters, 7 numbers, it is nothing but 7 factorial. Then number of A minus number of B plus number of elements in A intersection B we can find. So now if I are talking about string of 153 coming, then there are 4 more things to be arranged. So now what we are doing is in the first case A, 153 will come together, and then there are remaining. So 2, 4, 6 and 7. So we need to arrange these 5 quantities. So arranging 5 numbers would mean 5 factorial. Similarly, in the next case, we have a string of 2, 4, 6, 7. So we are left with 1, 3 and 5. So total arrangements would be nothing but 4 factorial. And if I take them together, in the next scenario, it is nothing but we have one string of 153, another string of 2, 4, 6, 7. Now this can be arranged in only 2 factorial ways. So if I simplify, my answer comes out to be 4898. Now in this next question that was asked in 2023, based on the strings of numbers, in this question they have clearly given that there are 3 digits already given. Now this is very important. If you try finding the digits, you will not get the right answer. They have already given the digits ABC, which are in AP. So what does that mean? These numbers are something like this, 2, 3, 4, but they're already given to you. Do not need to choose them. This is very important. So if this is an AP, even 4, 3, 2 will be in AP. So such kind of numbers are given. So now what they're saying is we want to make a 9-digit number using each of these 3 digits thrice. So for example, if this is the choice of numbers that we have, so we need to take 3 2s, 3 3s and 3 4s in order to make a 9-digit number. But the condition is that this combination of 2 3 4 or 4 3 2 should come at least once. So what we can do in this question is, if I start with this question, what I can do is I can take this 2 3 4 ones and tie them together using a string. And now what we are left with is 2 2 3 3 4 4. Now if I arrange these 7 numbers, I should get my answer. So if I arrange these 7 numbers, the answer is 7 factorial by 2 factorial, 2 factorial, 2 factorial. Since 2 2s, 2 3s, 2 4s are there, we can arrange this 2 3 4 as 4 3 2 also. So a 2 factorial for that. And this should ideally give us our answer. So if I simplify this, what I get is 1260. And that is our answer. Now this 2020 question that was given to us talks about application of Beggar's method in number based questions. So let us see what this question says. Question says that there is a 3-digit number. Let us take it as x1, x2, x3. This is made in such a manner that if I do sum of the digits, it is equal to 10. Now this is a clearly Beggar's method based question. So how to do this? So what we can do in this case is we can write the total number of solutions that are nothing but 10 plus 3 minus 1 C10. Now there is a problem in this solution. What is the problem? First problem is if x1 becomes 0, it is no more a 10-digit number. So this will happen when x2 plus x3 will become equal to 10, because in the same equation what I have done is I have put x1 equal to 0 in order to get this equation. So these are the cases that I don't want. To let us subtract the solutions of this. This is nothing but 10 plus 2 minus 1 C10, or nothing but 11. So these are 11 cases that I don't want. There is one more value of x1 that we don't want, and that value of x1 is nothing but 10, and 10 is one of the possible values. So if this happens, again we won't be able to get the right answer. So if I put 10 here, then invariably the other two things need to be 0. So this 10 0 0 is one case that we don't want. Let us also subtract this one case. If I remove these two cases, all the cases are relevant. And if I simplify this, this becomes nothing but 12C10 minus 12. So this becomes 12 into 11 by 2 minus 12. And if I take this 12 common, it is 11 minus 2 by 2. And this becomes nothing but 6 into 9. That is nothing but 54. Now again, this is same kind of question that we solved earlier, asked in 2021. So again, here they talk about nothing but 7-digit number. So x1, x2, x3, x7, this is how we can write it. And now what they're saying is all of these xi's are whole number lying between nothing but 1 and 3. So what they're asking is how many such numbers are possible so that the sum of this digit is equal to 10. Now directly I cannot apply, because then the minimum value of xi or any of these 7 digits can be 0 and maximum can be 10, and that we don't want. So what we are going to do here is we are going to do a small substitution. So instead of xi, let me put capital Xi plus 1. So what we are seeing is in place of x1 we will put capital X1 plus 1, so on and so forth. If I do that, the first term becomes x1 plus 1, second becomes again x2 plus 1. We can keep on doing till x7. And if I simplify this, what I get is x1 plus x2 till x7. This will be nothing but equal to 3. And when I'm doing this, what had happened is because of this substitution, this range has also changed. Now my xi will lie between 0 and 2. Now in the next step, what we can do is, in order to do this question, we can apply Beggar's method. If I apply it, it is 3 plus 7 minus 1 C3. But this is not the right answer, because still by applying Beggar's method, the maximum value of x that I can get in this equation is nothing but 3. So one solution would be 3 and others will become 0. What I'm saying is that those cases we need to subtract. So what are those cases? Let me write one of those cases. So one of those cases is when xi becomes 3 and then x2 to x7, all of these values will become 0. And you can see that such 7 cases are possible. So we need to subtract those 7 cases. And if I do so, I get my answer as 77. So you will have to apply Beggar's method to get to the answer. You can also apply method of cases, but I think this is simpler. If you learn 2 simple steps, this substitution and this removal of excess cases that are coming. Now a modified form of the last question was asked in 2023. In this question, what they are saying is, again they have taken 7-digit numbers only. And they are saying the sum of this digit is equal to 12. And now xi is nothing but a whole number that lies between 1 and 4. See, again we cannot directly apply because the number cannot take value of 12. So let us first put some substitutions, simplify, and then see what are the possibilities. So what we can do here is, I can do a very simple substitution. Xi is equal to capital Xi plus 1, and this is something that we did in the last question also. So in place of x1, I can put capital X plus 1. In place of x2, capital X2 plus 1. Like this, I can go till x7. Capital X7 plus 1 is equal to 12. So the value of capital X1 plus capital X2 till capital X7 will be equal to nothing but 5. And the value of xi, see, if you put this value here, the value of xi comes out to be between 0 and 3. Now again, the problem is that even if I apply my beggar's method, I will not get the exact answer. The reason is that the maximum value of xi can be 5. So if I write my total answers, that is nothing but 5 plus 7 minus 1 C5. I need to subtract two very important cases. One is when one of them becomes 5. So now let us see what can be those cases which are not acceptable. So now what we are saying is, if some xi becomes 5. So let us say that if x1 becomes 5, then x2 to x7, all of will become 0. So now this first number you can select in 7 ways. So 7C1 are the possible cases. So these 7 cases need to be subtracted. Then another important thing that we do not want is if one of them becomes 4 and another value becomes nothing but 1. This we do not want, because again 4 is not a permissible value. Now this can happen if out of 7, if I select 2 and assign them these 2 factorial values. 4, one can be 4, another can be 1, or vice versa. So in this many cases, what I have done is, out of those x1, x2, x3, x4, x5, x6, x7, I have selected 2. Let us say those are x1 and x2, and given them values 4 and 1. If I make this 4, this becomes 1. And if I make this 1, this becomes 4. And that is the reason I have put this 2 factorial in here. So this case also I need to subtract. So if I do that, I get my answers. If I simplify this, I get nothing but 413. So very interesting modification of the question that was asked in previous year, and hence solving PYQs is very important, because little bit of change here, there, and new question appears in the next year JEE paper. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.